Okay, question 1. So, transformations of graphs. So, the curve S has the equation y equals f of x, where f of x equals x squared. The curve T has the equation y equals g of x, where g of x equals 2x squared minus 12x plus 13. By writing g of x in the form, and this form is completed square form. Okay, so we've done completing the square before, and then it wants us to describe the transformations, which we can do in this form. So, step 1, we have 2x squared minus 12x plus 13. How do we complete the square? Well, first of all, if the coefficient of x squared is greater than or equal to, is greater than 1 or less than 1, we need to divide everything by that first. So, what are we going to do? Divide everything by? 2. Absolutely, we're going to take 2 out. Then what we're going to do, 2x squared divided by 2 is x squared minus 12x divided by 2 minus 6x. 13 divided by 2, 6.5 or 13 over 2. Preferably I prefer fractions. Okay, so I'm going to write 13 over 2. So we've divided everything by 2. We can now complete the square on inside the square bracket. Okay, so we know. How do we get minus 6x? It's x minus 3. There's loads of different ways we can do this. We looked at all the different ways, didn't we? Okay, so we're going to halve the coefficient of x, square it. We're going to minus 3 squared, which is 9 plus 13 over 2. This is how we've completed the square. Okay? And remember, there's that 2 on the outside. So then, before we multiply everything by 2, let's tidy this up. So we're going to get x minus 3 squared, minus 18 over 2 plus 13 over 2. I get minus 5 over 2. Yeah? And then I'm going to multiply everything by 2. So 2 lots of the bracket, and then minus 5. Okay? So some of you are happy with this way. Remember, there's loads of different ways. As long as we get that answer, that's the most important thing. So now it wants us to describe the transformation. Okay, just like BIDMAS. What do we do first? Brackets. Okay, tell me. Inside or outside the bracket? Who does it affect? What happens to our graph? Moves right by 3. Now, in maths terms, that's a translation. Translation, or translates 5 units to the... It's 3 units. I'm glad you guys are awake. 3 units to the right. Okay. Then what happens? What are we going to do now? It stretches. It's an enlargement. With who? Inside or outside the bracket? Outside. Who does it affect? Y. So then enlarges by 2 in y direction. Okay? And then what happens? Then, is this inside or outside the bracket? Who does it affect? Why? What do we do to the graph? Translate it down, okay? Then translates 5 units down. Okay, because we've written in this order, you are going to get full marks. Okay? However, sometimes in the mark scheme, what you might find is that what it does is, even though it stretches, it might have a vector and it does all the translations in one go. Okay, so your challenge is to see how that works. But that's nice and easy, 4 marks. Okay, question 2. Should be easy. Okay, so here we have a graph. It wants us to sketch this graph here. First of all, inside or outside the bracket? Inside. Who does it affect? X. What are we going to do to all our x coordinates? Multiply it by 2. So guys, what I do is I look at any points of, I was about to say momentum, but that's the wrong word entirely. Any points of, not intersections, but any I don't know what the word is. However, I'm looking for points that is going to make my life easier when I double this. For example, you can see here, there's a point here. There's a point here. It intersects here, and we have our minimum. Everyone happy? Yeah. These are the points I'm looking for, okay? Just now, what we're doing is we're doubling all the x values. So instead of it being minus 2, it's now minus 4. Instead of it being 4, it's now 8. Instead of it being 3, it's now 6. Now my y is not going to change. Instead of it being minus 1, it's minus 2. Minus 1, instead of it being 1, it's 2. So this is my graph. Now forgive me, I am a terrible drawer on this iPad. However, you should be sketching. It should go through all the points. Ooh, doing well so far. Okay. Should be using a pencil. There you go. Now, you need to make sure you get all those points correct for the 2 marks. Okay? In the mark scheme, it will say something like if you get 3 out of the 5 correct, then you get 1 mark. Does that make sense? So make sure you have all those points. It's not asked us to write down our coordinates, so this would be fine. Now, here we go. So from the original graph, this is now the graph of x plus k. So what's happened to the graph? First of all, inside the bracket, who does it affect? X. We know it affects x, so, and because it's a plus k, it means we're actually moving to the left. Okay, move to the left. Now, it's really easy when we just use our minimum point. Our minimum point here was 1 minus 4. How much have we moved to the left by? 3. So what does our k equal? 3. F of x plus 3. Perfect. Well done. Because then we've gone negative 3. Yeah? Awesome. Nice, easy 1 mark. Okay, here we go. So here we have a graph, and it says the coordinates of the minimum point of 3 minus 4. Write down the coordinates of the minimum point of this. Now, these are really easy questions with low marks. And as I said, you know, in your GCSE, this is probably going to be on 1 paper. Why is this useful, though? We are top set. We are going into A-level. We need to understand this because this is a big part of A-level, okay? So, is it inside or outside the bracket? Who does it affect? What are we going to do to the x coordinates? Add 4. So instead of it being 3 minus 4, it's going to be 7 minus 4. Because I added 4 to my x coordinates. Okay, inside or outside the bracket? Who does it affect? Y. What do we do to our y coordinates? Times by 3. So it's only my y, so my x stays the same. Minus 4 times 3, minus 12. Easy. Inside or outside the bracket? Who does it affect? X. What do? The opposite, so we double it. 3 doubled is, and our y stays the same. Look how easy those 3 marks are. Nice and easy. This is another topic on the assessment you can do. Okay, so someone just asked a question, and I'm going to just make it a little bit more. What if it was 3/4 of x? What would we do? And then divide by 3. Or divided by 3/4, okay? Okay, if we just do the opposite, if it's 3/4 times x, we're going to do our x coordinate divided by 3/4. Brilliant. All right, so it says the curve with the equation is translated to give the curve C. C has a minimum point with the coordinates 3, 5. So we've gone from 3 minus 4 to 3, 5. It's told us the translation is f of x plus k. We can clearly see our y coordinate has been effective. How did we go from minus 4 to 5? We added 9. Brilliant. So k is 9. Minus 4, how do we get to 5? We've clearly moved the graph up by 9. Yeah? It's a translation, and the graph has gone from here up to here. Okay? Okay, question 4. A curve has the equation y equals f of x. The coordinates of the minimum point is minus 9, 15. Write down the coordinates of the minimum point on the curve with the equation y equals f of x plus 3. Inside or outside? Who does it affect? What do we do to the x coordinates? The opposite, we take away 3. So instead of minus 9, it's minus 12, and my y stays the same. Simple. Okay, y equals a third f of x. Is it inside or outside? Who does it affect? Y. What do we do to the y coordinates? Divide by 3, or multiply them by a third. Either or is the same. So my x stays the same, minus 9. 15 multiplied by a third is 5. Perfect. Here we go. This is a lovely question. Right, this is what we're here for, really, is sine, cos, and tan. Yeah? Trig graphs. So the graph equals y equals a cos x plus b. What does that mean has happened to this graph? So first of all, inside the bracket, x. What's happened? We've Yeah, we've translated the graph. We've moved to the graph either left or right, haven't we? Okay, what does the A mean? Outside the bracket, what have we done? We've stretched it, yeah? Stretch enlargement. So it's gone from this big to this big, yeah? A times bigger, isn't it? For the Y. And then for B, we moved, if it's plus B, we moved left. B. Okay? So, let's have a look. Cos. Trigonometric function. What do we know the cos graph looks like? The cos graph looks like this. Between 0 and 360, it starts at 1. So, maximum 1, minimum -1. Crosses at 90. This is 180. This is 270. This is 360. So, how have we gone from our cos graph to this one? I'm going to give you a minute to notice what's happened. See if you can figure out this A of B. Now you know what the original graph looks like. See if you can have a look at this. Okay, so we know straight away that our minimum and maximum points, we can see from the graph that really they should be at 1 and -1. They've now at -2 and 2. So we can tell straight away that A is 2. Okay? Now, also, it's told us in the question that A is greater than 0. So this makes sense, right? A is 2. Then the next one. So you guys gave me two answers. You said it could be 90 degrees or -270 degrees. Both are correct. However, the question says that B has to be in between 0 and 360. So it has to be positive and less than 360. So well done for thinking outside the box. Make sure we read the questions to really understand. So it is 90. What's happened is this graph has been moved. My new axis is now here, isn't it? Yeah? Absolutely amazing. 2 marks for that. Doesn't seem a lot of marks for all the knowledge we've had to acquire for this. However, it's a great understanding. So the graph has now done this. Look, I'll show you. The graph has now moved to here. Okay. And then what's happened is actually we stretched it like this. Oh my God, this is a terrible drawing. Okay, but this is what's happened. It's moved to the left and then we stretched it. And that's how we ended up with this perfect drawing over here. Okay, question 5. Okay, so nice and easy for part A, I, and II. So here we grab our graph. We have our maximum 0.46. Okay, first one, inside or outside the bracket? Who does it affect? X. What do we do to all the X coordinates? -4. So 0, 6. Perfect. Next one, inside or outside the bracket? Who does it affect? What do we do to the X coordinates? Yeah, we divide by 2, half it. 2, 6. Awesome. Okay, part B. So the equation of the curve is y equals x squared plus 3x plus 4. The curve is transformed to curve S under this translation. So what does this translation mean? It means it's 4 to the right and 6 up. Everyone happy that this is x, y? Now, if I was to write this in a function form, technically I'd say f of x minus 4 plus 6. Okay, so let's make sure we're happy with this. Now we know this is function form. We know f of x, our normal function they've given us, is x squared plus 3x plus 4. But what have we done to this function? We've minus 4, so we've added 4 technically to all the x coordinates and then added 6 to the whole thing, right? Now, this is all a game of matching. Watch me match. Really simple. Spot the difference. So here's an x. What's happened to this x? Like what we see straight away. It's a minus 4. So everywhere we see an x, we're now going to write x minus 4. Okay? Oh, sorry, I coloured that one a bit. Then we have our plus 4 on the end. There's no x there, so that's it. Okay? Everyone happy with that first step? Right, the second step. So now, what have we got? We've technically got the function of x minus 4. This is what this equals. The function of x minus 4 equals this. But what do I want? I want the function of x minus 4 plus 6. So, how am I going to get that? I'm just going to have all of my function, and wherever there's an x, I put x minus 4. And then I've got my plus 4. And then what do I need to do? I need to add 6 on the end of it. Now it says you do not need to simplify the equation, so you can leave it like this. But that is the answer. Okay? Okay, watch this part again. Keep watching it until you understand it a bit more. What you have to remember is this. The plus 6 is outside the whole equation. This is the whole equation, so I need to add 6 on the end of it. This is where the add 6 comes from. Then, what have I done to all my x coordinates? I've minus 4 from them. Sorry, not my x coordinates, my x values. I've minus 4 from them, so I need to make sure that's shown within this. So I've got minus 4 plus 6. Okay? Watch it again. Keep watching it. It will make sense. Okay, the curve C has this equation where 9 minus 3 lots of x plus 2 squared. This is in completed square form. Now, we know in completed square form, we can find the minimum or the maximum of a quadratic. Now, we're going to find the maximum. How do I know this is a maximum quadratic? How do I know that this quadratic is going to give me a maximum? Anyone know? It's a negative quadratic. If I was to expand this, I'd end up with minus 3x squared. A negative quadratic looks like this. So we would have a maximum point, okay? A positive quadratic would look like this, smiley face, so we have a minimum point. So how do we find this point? Right, what makes this bracket 0? When x equals minus 2. When x equals minus 2, what does y equal? When x equals minus 2, what does y equal? 9. If I put minus 2 in here, I'm going to get minus 2 plus 2 is 0. Minus 3 times 0 is 0. I'm just going to be left with 9. So our maximum coordinates is minus 2, 9. Okay, guys, so y equals 9 minus 3 lots of minus 2 plus 2 squared. So I'm technically getting 9 minus 3 lots of 0 squared, which is 9 minus 0. What's minus 3 times 0 squared? 0. We're just left with 9. Okay? So step by step, that's how we do it. Right. The curve C is transformed by 4, 0. What's happened here? Moved to the right by 4. Has anything happened to... No. Find the equation of S. So if it's moved to the right by 4, we're technically doing f of x minus 4, aren't we? Yeah? Okay, guys, same as before. So if f of x equals 9 minus 3 lots of x plus 2 squared, if I want f of x minus 4, what do I have to do everywhere there's an x? I need to substitute in x minus 4, so 9. Oh. So I'm going to get 9 minus 3 lots of, I'm not going to write x, what am I writing? X minus 4 plus 2 squared. Can you see how I've completely substituted that in? So then I simplify, I'm going to get 9 minus 3 bracket minus 4 plus 2? Minus 2 squared. So there we go. This is the new graph. Okay, this is a function. Right, next up, it says the curve C is transformed to the curve T. The curve T has this equation now. So remember, before it was 9 minus 3 x plus 2 squared. Now it's gone from this to this. Guys, can you tell me what's happened?
It went down by 9 and enlarged by 3.
Okay, so it went down by 9 and enlarged by 3. However, if it went down by 9, are you saying that we minused 18 from here? Is there a, you're saying it's gone from, this was the original 9. So 9 to minus 9 is minus 18, isn't it? Yeah? However, how have I gone from minus 3 to positive 3? Okay, we really need to think about what's happened. It is a reflection. Well done. So what's happened here, technically, is we've gone from f of x 2 minus f of x. So this is a reflection. Does anyone know if it's on the outside where we're reflecting? Yes, we reflection in the x-axis. Perfect. Okay, if you just write negative f of x, I'm not sure if you get the mark. It does say describe fully. I think it wants a sentence. Reflection in the x-axis, full stop, capital letter at the beginning. Yeah? Just because we're in maths, we don't forget English, yeah? Okay, question 7. Oh, right. Okay, so step 1. So a lot happened to this graph. A lot. We have an A, B, and a C. It's only worth 3 marks. Okay? So the first thing I'm going to do, what graph is it? Cos. First thing I'm going to do is I'm going to draw the original, the OG cos graph. Yeah? Are we ready? So let's go. So we're going to draw the cos graph, which we all have memorized, don't we? Yeah? We have an x and y. Cos cuts. Okay? That's how I remember it. It cuts. Cos cuts the y-axis. So I know, so you know sine starts from here. Well, cos cuts it, so it starts from here. Goes down and up. Now, my maximum is 1. My minimum? Minus 1. These are what we need to remember. This is my maximum y coordinate. Okay, what's this point here? 90. What's this coordinate? 180. What's this coordinate? 270. What's this coordinate? 360. Nice and easy. Okay, guys, so I've done the OG cos graph. Done. I need to now know, how do I get from there to the original one? Well, first things first. I want to know what's happened to the graph, actually. Okay, when I look at this, remember we have to do it in a set of steps. Okay, what's happened to this graph? What's happened to it first? Inside the bracket. It's, who does it affect? X. So what have I done to all my x coordinates? I've added b. Yeah? Then what did I do to my y coordinates? I multiplied them by a. Yeah? Then what did I do to them? I moved it up by c. Then it went up by c. Okay? I need to understand what I've done to this graph before I even look at how to do this. So what I want you to do now is to give this a go. Okay, so first of all, what do we notice? We've noticed, if we have a look, it's always good to pick out the points of... that word has really gone from my mouth. I can't think of the word. Anyway, the key points, should we say. So we can see here we have a minimum. What is this minimum point? It's 180 minus 1, yeah? Now the minimum point's here. It's now at 90. So what does that mean? We've moved... 90, yeah? Okay, to the left. Okay, so technically, we've gone to the left 90. Now, it says in here minus b, so technically we need to write minus 90 in there to get it to be a plus. So we need to write a as minus 90. Right, now, sorry, b is minus 90. Okay, then, so we've already moved it. Everyone happy we moved it? Yeah. Now, what do we notice our length is between 1 and minus 1? 2. So our length between our maximum and our minimum now, between 5 and minus 1, it is 6. So how have I gone from 2 to 6? What have I enlarged it by? By 3. Multiplied it by 3. 2 times 3 is 6. So my A is 3. Then, part C, I've moved it. Technically, this minimum point should now be, if this is 3 and this is minus 3, so my minimum point has moved here to 90 minus 3. It's now gone to minus 1. So then what have I done to it? I've moved the graph up by 2. Okay. Let that sink in. Okay, question 7. Let's end on a really easy one then. So, 5, 7 is the maximum. F of x plus 9, inside, outside the bracket? Inside, who does it affect? What do we do to x? Minus 9, so what do we get? 5, oh, no. -4, 7, perfect. Okay, last, inside or outside the bracket? Who does it affect? Y, what do we do? So, 5, 10. Perfect. Normally you get more questions that look like this than the sine and cosine ones. However, it's good to know everything, yeah? Okay, well done.